Hey everybody, welcome back. So in the last video, we talked about how a positive lens or converging lens can form a real image. And in this video, we're going to look at two examples of that, two simple optical systems. One's called the simple camera and one's called the simple projector. And whether this single positive lens is acting as a simple camera or projector really depends on how far the object is from the lens, as you'll see. So let's talk about the camera first. So the camera is going to be a positive lens with the object relatively far away. And what I mean by far away is compared to the focal length of the lens. So let's go ahead and do the ray trace. And I invite you guys to try this on a piece of paper. Try the ray trace yourself with a pen or pencil. So the first thing you would do is just draw a horizontal line that represents the optic axis. The next thing you do is just put a generic positive lens here, centered on the optic axis. Some people don't even draw the lens shape. They'll just draw a single vertical line. What they'll actually do is they'll draw, this is not that important, but I'll go ahead and mention it. What they do is they would put their optic axis like this, whoops, and if they wanted to represent a positive lens, a converging lens, they draw a single line with two arrowheads like that. And that's supposed to represent that this lens is thicker in the middle than at the edges, the fact that these triangles are like that. So some ray traces, if you look up ray tracing on the internet, you might see diagrams where the positive lenses are represented by these lines with arrowheads. I just draw a generic lens that's thicker in the middle like that. Okay, but either way you want to do it is fine. The next thing you're going to draw are these two focal points. So draw 2 points on your optic axis that are the same distance from the approximate center of your lens. These two focal points, again, are really critical reference points to do the ray trace. So what I mean by object far away is the object distance from the object arrow to the lens is a lot bigger than the focal length from a focal point to the lens. Well, really, by definition, from the lens to the rear focal point for the positive lens. But the focal length, the absolute value of the focal length, is going to be the distance from either of these points to the middle of the lens. So after you draw these 2 points, if you want to do the camera ray trace, you just have to make sure, you have to remember my object's far away. So draw your generic object arrow so that it's relatively far away from the lens compared to the focal length. So you just draw an upright arrow. By convention, we always draw the object arrow to be upright like that. And now you're ready to start the ray trace. So remember, you're going to draw 2 rays from the tip of the object arrow. The first ray that you're going to draw will always be parallel to the optic axis. And if it's parallel to the optic axis, we know that any ray parallel to the optic axis for a positive lens is going to get refracted through that rear focal point. So you just draw that ray. You make one bend in the middle of the lens. That's our shortcut, and there it is. The second ray, so again, you can try that on your own on your piece of paper there. The second ray that you're going to draw is, and we always draw this second ray the same way, no matter if it's a positive lens or negative lens, you're going to draw a straight arrow from the tip of the object right through this center here, this intersection point, or the center of the lens with the optic axis. So there it is right there. I drew it as a blue ray. Okay, that's it. You're done with your ray tracing. Now you ask yourself, well, when these rays leave the lens, are they converging or diverging? Are they getting closer together or farther apart? Well, these are getting closer together, so they're converging. So where do they intersect? Right there. That is the tip of the image arrow. So now all you have to do is draw your arrow. You always start from the optic axis. That's going to be the base of your arrow. And here we have to go down. So we're going to get an image arrow like that. And we did it. So how would we describe that image? Well, it's definitely real because it's converging rays. And in this video, we're only looking at real image formation. it is inverted, right, upside down compared to the object, and it's going to be much smaller than the object. If the object is way out here to the left, you're going to get a tiny image. But notice where it's formed. It's formed very close to that back focal point. So the image distance from the lens to the image is just a little bit bigger than the focal length. That's characteristic of a simple camera. Okay, so we get, as you see here, a real small inverted image close to the lens. Just outside the focal point, just to the right of the focal point. Why do we call this a simple camera? Because this is how camera lenses usually operate, right? If you even think of your phone, right? Because everybody pretty much uses the camera on their phone. So you have that lens, the objects, the things that you're taking photos of are relatively far away from that lens. And think about this. The image has to be formed inside your phone on that CCD array, on that detector array, and that light gets focused on those pixels on that array. So the image distance is really small. Those lenses have a very short focal length. Okay, so that's why we call it a simple camera. And even in a conventional camera, not the camera on your phone, the same thing applies. The objects are relatively far away, and the image has to be formed on that array inside your camera, the housing of your camera. So that's why we call it a simple camera. Okay, now that's to be contrasted to the simple projector, but this is still real image formation. So we put the object closer to the lens, but it is still outside the focal point. That's key. Because if the object gets moved in between that front focal point and the lens, we actually get virtual image formation, which we'll look at in the next video. So if you're going to do the ray trace for this one, what you got to do is, again, draw the optic axis, generic positive lens centered on the axis, and then boom, boom, boom. Just draw 2 points, some distance from your lens, same distance from the center of the lens. And for the projector, put your object arrow close to the lens, but still outside. That means to the left of that front focal point. Okay? Now, do the ray trace. So the first ray, parallel to the optic axis from the tip of the object arrow, and that has to go through the back focal point. The second ray, no matter what, just goes right through the center of the lens, straight like that. And look, again, we are getting converging rays. They are meeting, but where are they intersecting? Oh, way out here, down here. So now we just draw in the image arrow, boom, right there. Oh, my arrow's not quite at the intersection point. I did a bad job with my PowerPoint drawing, but it's almost at the intersection point. All right, so what type of image are we getting? Well, we're getting a real image. It is much bigger than the object for most projectors, so it's larger than the object, and it's inverted. It is upside down compared to the object. Okay, now, why do we call this a projector? Because this is how an actual projector works. Think of the projector in our classroom, right? So up there in that projector, you have a lens there, and the object in that case is actually an LCD, a liquid crystal display screen that light it gets sent through. So it's actually a transmission object. But that light is then focused and imaged on the screen at the front of the room, which is much farther from the lens, and that image is much bigger than the actual LCD screen that the light is being sent through. So that LCD screen is acting as the object. Okay, so that's why we call this a simple projector. And I assure you that the image is inverted, right? So what we see on the screen is upside down compared to what is displayed on that object display inside the projector. Okay, so you should know what we mean by simple camera and simple projector. Both are positive lenses, Camera object is far from the lens, forming a real, inverted, tiny image close to the lens. The projector, positive lens, but now the object is close to the lens, but still outside the front focal point, and we're getting a real, much bigger image, inverted, right, far from the lens. Again, those are all general terms, but you should know them. Okay. Now, I wanted to show you guys this applet that you can play around with, where you can look at the camera and the projector. Yeah. Okay, that's it for my PowerPoint. So let me go to this. I'll show you where this applet is. It is on our course page. So if you go to the course page, right down here, again, we've looked at these two applets above here. I want to do the positive lens ray trace. So let me do that. And again, if you want to run these applets, you're going to probably need some sort of applet extension. So again, I found one for Chrome, and let's see, well, hopefully it'll load. Let's see what it's doing. It's initializing. Okay. And it's loading, and it finally appeared. Okay, so let me move my capture screen over a little bit. All right, I think you can see that. Okay, so what you have here is, this is the optic axis, and that cyan thing, that represents a positive lens, and these two little vertical dashes represent the two focal points. The red arrow is the object, the blue arrow is the image. Okay, so what you can do is you can move this, you can just grab it with your cursor and move it around. So look, here's a simple camera. See, I put the red arrow, the object arrow, far from the lens. The green rays are it shows you the actual path of the rays, or the green lines. Okay, so you can see here are two rays, the one parallel to the optic axis, and it goes through that back focal point. The other ray goes straight through the middle of the lens. They're intersecting, and there's your image right there. So that's the simple camera, right? Object far from the lens, real inverted image, smaller, much smaller than the object, formed close to the lens. Now, if I move this arrow toward the lens, you can see what's happening. Look, the image, the real image, is being formed farther from the lens, and it gets bigger and bigger. So here, I'm about to move it off the applet screen. That would represent a simple projector. See, now the object is close to the lens, but still to the left, outside that front focal point. The rays are intersecting here, and here's my real inverted, much larger image formed farther from the lens. Okay, now, this is leading to the next video, but if I keep moving, I'll show you, if I keep moving this arrow, watch this, pretty neat thing happens. If I put it right on that front focal point, interesting thing occurs. The rays that leave the lens are actually parallel. So they're neither converging nor diverging. So we actually don't get an image formed. Although in some optics books, they call this, well, yes, an image is formed at infinity, which is highfalutin language, meaning the rays are parallel, okay? Now, what happens though? Watch this. If I bring this inside the focal point, if you do the ray trace, and again, it's the same two rays, you obey the same rules, you find out that the rays are diverging. So you trace them back, and that's what you see in this yellow. If you trace those diverging rays back, boom, you actually form a virtual image. But I'm getting into the next video, so I'm going to stop. And we'll talk more about this in the next video. Bye.